continuing conversation about careers in data science and the future of data science, and share like the computing power and so many other interesting things that are evolving out of the research happening in universities. We have with us Umang Chaudhary. He's a data scientist at the Data Science Institute at Vanderbilt University, Nashville, Tennessee. Love to have you talk to us a little bit about the future of data science and explore all these aspects.
Yeah, I think data science is definitely, a lot of people call it the next big thing in several different industries, and I definitely think that's true. In terms of the next big thing, I think a lot of push that we're getting is definitely from hardware. We, very, very powerful GPUs and just machine learning model accelerators are becoming easier to access. So for example, we just at Vanderbilt bought 2 new DGX A100 GPUs, which are essentially state-of-the-art supercomputers that can be used to train really, really big deep neural networks. And I think that's definitely somewhere data science is going to start becoming really, really useful and also very easy to use. So now deep learning has kind of like moved on to this new thing called a foundational AI model, which are transformer-based models. And essentially what they are they're taking the ability of natural language processing, the ability of computers to understand contextual data, and kind of like translate that into predictions of whatever sort you want. So transformer models are essentially going to be the foundation model type of pretty much any predictive activity that you want to do. And these models can work with text, they can work with, regular tabular data, they can work with audio, video, images, and essentially these models, you can pre-train them to do a specific certain type of task. And then all you need to do is, fine tune them a little for them to be applied to pretty much any domains. For example, if you develop a machine learning model that summarizes text in general, you can train it even more on a specific domain like history. And then you can take, large collections of, historical text and essentially summarize them. And these models are doing a really, really, really good job of capturing the most important elements from paragraphs and, essentially cutting down the amount of work that perhaps a historian has to do. And, these models are now also being used to transcribe written text, really, really old written text into computer readable text. And therefore, then you can do analysis on it now because you've transcribed it from analog to digital really easily. And you do that using really 4 lines of code now. So I think that's really the future. They're starting to build a really, really powerful online repository of all these models that people are sharing. Google is sharing these models, Facebook is sharing these models, and they're available to use for anyone. So if you have your own set of text data, you can take that and you can run analysis on it of whatever kind you'd like. You can ask questions off of these models. So there's question answering models. There's, if you want to capture concepts that are similar across multiple paragraphs, you have a model for that. So it's really cool. You can take these, basic models and you can build on top of them with very few lines of code. And it can help you solve data science problems that up until this point were essentially impossible to do. So I think that's really where data science is going to head forward with transformer models.
So like many other computer science fields, these repositories and models that exist have done most of the hard work. The students really don't need to learn how to do the raw code. But it's more like a librarian's job that you need the right book for the right reference.
That's how it's starting to become. Like at Vanderbilt now, what we're doing is we're not necessarily, unless these professors need our help to like really do a very complex a data science problem or a machine learning problem, what we've started doing is we've started training these professors using these transformer models where they really need to write like 4 or 5 lines of code. And they're just doing their own machine learning projects now. And these are, like historians who barely have ever used technology in their research, and now they're just completely changing their field because they have this sudden amount of computational power available at their fingertips very easily, which otherwise, especially in the field of history, it's kind of like never happened. Everybody's just, writing papers and reading papers, but now you can, take 10,000 articles published in the New York Times and you can just ask a question, how many articles talk about pandemics? And then, over 300 years of newspaper articles, you can just immediately get all the newspaper articles that talk about pandemics. So it's really, really powerful, and people are doing some really, really cool things to kind of change their own fields just because they have such easy access to, these models. All they need is a little bit of push, a little bit of guidance in the right direction, and pretty much know how to Google what you're finding. And then you'll have a model for your work without having to do all the legwork.
I think the keywords that you mentioned were push and guidance. And I think the example that you gave for historians to sort of use data science tools and models is very appropriate. But do you see that there's this fear of using technology, and a lot of your work is to demystify it and make it simple for everyone who's walking your door?
Especially with these models, because they're like, once they've been trained, they were of course trained on very, very computationally intensive, those trainings were very computationally intensive. You need the hardware for that. But now once it's trained, all you really need is, a regular PC, and it'll just run it, or you can run it online. They've started offering resources to kind of, they've started offering computational power online. So you just write your code on an online interface and it will run all your code in the back end. You'll pay a small fee for it, but you'll get all your work done without actually having to buy, a $500,000 machine.
Thank you so much. It was just such a joy just having this conversation with you, and really look forward to following your journey and learning more about great things that you're up to at Data Science Institute. So long, and all the best.